Now we are going to discuss about potential difference, potential energy, right? So we have just discussed about electrostatic potential and potential difference. Fine. Now we are going to discuss about electrostatic potential energy. So what is potential energy, right? So you can see one term is there, that is energy. If you see one word I have used, energy. So I guess you know what is an energy, you know or not, what is an energy? So energy, if you have energy, then only you can work, right? And if I say if you are working, then definitely you must have some energy, right? So energy and work are almost same only basically. If you have energy, then only you will be able to work, right? And if you are working, right, if you are working, then I will assume that you must have some energy. That's why you are able to do some work. Fine. So they are directly related to each other, and work and energy are almost same. For example, let's say कि I take again plus Q charge here. It has some electric field here. Fine. It is a plus Q charge here. Electric field here. I take plus Q charge again, unit positive. I just say this is a unit positive charge, or I'll just say plus 1 coulomb. Fine. It is at infinity. Fine. It is at infinity. So if I need to bring from this point to here, let's say point A, right, and again to point B. Fine. So what will be the potential energy? What will be the potential energy of the system? So basically, if you need to define this, how will you define? You will just define as potential energy of a charge at a point is the work done by external force in bringing from infinity to at that point, or at the certain point. Fine. So if you read the definition, see, potential energy of a charge at a point is nothing but the work done by the external force from bringing force in bringing from infinity to at that point, right, or at the certain point, means at the fixed point, like this point or this point, right? So the amount of work that you will do, right, that will be nothing but a potential energy of a charge, right? That will be the potential energy of that charge. Fine. Now let's see what is potential energy difference, as we have discussed as your potential difference, right? So now we will discuss potential energy difference. So how to find the, let's say, how to find the potential energy difference from these 2 points, point A and point B. So I guess you know potential energy is denoted by U. Potential energy is denoted by U. Fine. So we want the total potential energy, or I just say I want potential energy difference. Delta represents the difference. This is called delta, right? Delta represents the what? Difference. So we want potential energy difference from point A to point B. Always remember, whenever you find potential difference or potential energy difference, we always find from point A to point B. Is it clear? That how much work you have done from to bring a unit positive charge from this point to point A and from this point to point B. Is it clear? Fine. So if I need to show you delta U will be equal to what? Tell me. Delta U will be equal to the energy, right, from B. So tell me where you will require more energy. You will require to bring a charge from this point A and after point B, right? So point A तक लाने में ज़्यादा एनर्जी लगेगा ना point B तक लाने में ज़्यादा एनर्जी आपका वेस्ट होगा? कौन सा पॉइंट में आपका ज़्यादा एनर्जी लगेगा? टेल मी. So obviously the answer will be the more energy you required to bring at point B. हमें B तक लाने में ज़्यादा एनर्जी वेस्ट होगा मेरा, है ना? So obviously whenever you find difference, right? So more minus less हम ऐसे करते बेसिकली, है ना? So UB means energy to bring from infinity to point B, ठीक है, minus UA. Fine. So if I need to find the potential energy difference, so it will be what? UB minus UA, right? Or you can write as this also, like in terms of work, WB minus WA. Fine. Is it clear? और आप लोग देखोगे बहुत सारे बुक में है ना, इन मेनी बुक्स यू विल फाइंड दिस एज रिटन एज UAB and WAB. This kind of thing is being written there. Fine. Means work done to bring from point A to point B, or potential energy difference from point A to point B. Fine. From point A to point B, point A to point B. This work and energy are almost same things. Is it clear, everyone? Now we will move to our next topic, that is derivation, right? Now we are going to derive one formula, right? Now we are going to derive one formula for the electrostatic potential. Fine. So let's write the topic now. So your next topic will be electrostatic potential due to a point charge. So now we are going to find how much potential, right? How much potential is required by a point charge, right? To, let's say, if I consider this as a point, let's say I consider a point charge plus Q. Fine. I consider this point charge as plus Q. Is it clear? So I need to find the potential from this point to, let's say, at point P. I want to find the electrostatic potential at point P. Means how much work I would do to bring from infinity, let's say from infinity, how much work I have to do to bring a charge from infinity to at the point P. Fine. The force is nothing but your plus Q. Fine. So let's say the distance between plus Q means, let's say this is point O. I consider this plus Q is situated at point O. Let's give some name. Let's say this is Q. At point A, plus Q is there, right? Means 1 coulomb of charge is there. Some charge, or not 1 coulomb, some charge is there, right? And we want to find the electric potential at point P due to this point Q. Fine. Again I am repeating, we want to find the electrostatic potential at point P due to this charge. Fine. So obviously we will bring a charge from infinity, right? So let's assume that I bring from infinity. At that first I'll do some work till point A. I just have brought this here. Fine. At point A. Fine. And the distance between point means from O to point A is, let's say, X. The distance between point O to point A is, let's say, X. Fine. The work means the distance between these 2 points is X. Fine. After again, if I say after this point, after point A, let's say this has moved to point B. This has moved to point B. So see, if this will move to point B, so it is a small distance, right? It has just covered a very small distance. Is it okay? So if it is very small distance, so it will be represented by what? dx. I just have taken as dx. Now you must thinking why dx sir, dx क्यों लिया? See, small distance, that's why I've used as d, right? Now x, you must thinking why I have taken this x, why not r? Suppose this is r, from O to P I have taken as distance is r, right? So why not dr, why not other things? So answer is very simple, because this from O to A, right, to total distance how much? X, right? And when it move to point A to point B, it is the distance is just a part of x, right? The distance will be just a part of x only, isn't it? Fine. So I have just considered this distance means from A to B is how much? Dx. Is it clear? Everyone clear or not? So let's write about it. So write it. Let us consider a point charge plus q at a point O. Now see, as you can see, right, let P be a point at a distance r from O. Fine, this part is clear, I guess. Now let us consider a point A at a distance x from O. Fine, from O. Now tell me, what will be the force, right? What will be the force on this point A due to the charge Q, right? क्या फोर्स, ये जो प्लस क्यू है ऑब्वियसली कुछ ना कुछ फोर्स यहाँ अप्लाई करेगा, है ना? बिकॉज वी हैव लर्न फ्रॉम द लॉ ऑफ ग्रेविटेशन, क्लास 11 में पढ़ा होगा कि नहीं है, कि ईच एंड एवरी ऑब्जेक्ट इन दिस यूनिवर्स अट्रैक्ट ईच अदर, है ना? एक दूसरे को अट्रैक्ट करता है. सो ऑब्वियसली कुछ ना कुछ फोर्स तो इसके ऊपर जरूर दे रहा होगा प्लस क्यू, है ना, एट पॉइंट ए, राइट? सो नाउ वी राइट द हाउ मच फोर्स इज गिवन बाय दिस प्लस क्यू चार्ज एट द पॉइंट ए. फाइन. सो राइट. So the force on point A by the source charge is given by, or is given as, you can write as. So you know what will the force, what will be the force? You have already got in the first chapter, you have already got in the very first chapter. F will be equal to what? 1 by 4 pi epsilon naught into q by r square, right? It was q by r square, right? But at this point, what is distance we have got? It is x square. Is it clear? And what is direction? Along OA. Means the electric field is in this direction, right? Since this is plus q charge, this is also plus q charge, I have taken here as a plus q charge only. Fine. Plus 1 coulomb, right? So plus q means what? Plus 1 coulomb I can say here easily. So since both are positive, so it will the natural force will be what? The force of repulsion. The natural force of will be what? Force of repulsion, but not force of attraction. Always remember plus plus. So there will be genuine force of repulsion. So electric field will be outward, in the outward direction. If it would have been negative charge, so the electric field would have been inward direction. Fine. So it will be along OA. Is it clear this part or not, everyone? Now tell me, if I bring from this point A to point B, I will have to do some work or not? I will have to do some work or not, right? So you can write work done from A to B, right? So if I do some work here, so work from A to B, work done from A to B will be how much? Work done from A to B will be how much? F into dx, isn't it? It will be F into dx, because you know work equal to nothing but force into displacement, or distance, right? So force is there and distance how much? How much distance is covered or displacement from A to B? It is dx. So it will be F into dx. Now just put the value of F, that is force, here, replace it, right? Substitute the value of force in this equation. So you will get 1 by 4 pi epsilon naught into q by x square into dx. You will get something like this, isn't it? Now, but see, one thing we have missed here. I guess everyone have missed this one thing. See, this one I have done intentionally. When you write this, you go in such a flow that you miss one thing. See carefully, there is what? Dot. So it is a bit basically what? A dot product, right? So we must bring in terms of magnitude. It will be what? F dx cos, right? Theta, cos theta. Now what is the angle formed from A to B? See, it is a straight line or not? Angle formed is what? 180 degree. See, it is a straight line. A to B is a straight line. So angle will be how much? 180 degree. So it will cos 180 degree. Fine. So now we have broken this in terms of magnitude, right? Since it was what? In terms of dot product. So it will be what? In terms of cos theta. So theta is how much here? 180 degree. Now tell me, what is the value of cos 180? I guess we have done, right? So value of cos it is how much? Minus 1, right? So it will become what? Minus f into dx. Now it is a proper one. Is it clear? Please don't do mistake that. I have done that intentionally because many of you will do in your exam same kind of mistake. You just move in a flow, right? So please don't do that mistake. Now see, let's put the value of f here. What we have got? Minus will there, minus 1 by 4 pi epsilon naught into dx how much? Sorry, I missed one thing now. Q by x square into dx. So this amount of work is done from A to point B. Now if I want to find the whole work done from A to point point A to point P, what shall I do? I'll just integrate this. So we know if we want to find whole as a whole, right, the substance, so what we do basically, we do just the integration, right? We just add up, we will just add up all the things so that we will get the what? We will get our result. Is it clear? Now what we will do? We will do integration here. So now write net work done in moving a unit positive charge from infinity to point P, right? So see, now we are finding the total work done from A to point P, or you can say from infinity to point P basically, not from point A. We have just considered the point A as an arbitrary point, right? Fine. Now we will do some work from infinity to point P, means whole work, how much work is done from infinity to point P. Now see, what we'll do? We'll just do integration. So it will same. Now see, if you integrate this, so what will be the limit? It is from infinity to what? And a distance r. So limit will be what? Infinity and r. From infinity to distance r will come. सी दिस इज व्हाट इज डिस्टेंस हियर r, यहाँ पर देखो डिस्टेंस क्या है इसके आपका, ये डिस्टेंस r यहाँ पे है कि नहीं है. सो हम लोग का लिमिट क्या होगा, इन्फिनिटी टू r. ठीक है, नाउ जस्ट पुट इट हियर, व्हाट विल गेट हियर, like f dot dx. Fine, now just put the values of f dot dx. How much you have got? So you will get as minus 1 by 4 pi epsilon naught q by x square into dx. Fine, you get this. Now see, this and this is a constant term, right? So it will come out. So it will come out. So it will come out. What will get? See, this is not a b. This will be total work done, right? Now this will be total work done. So w, that is work, total work done, will be equal to minus 1 by, or I can write q by 4 pi epsilon naught integration over infinity to r will get as 1 by x square dx, isn't it? We'll get at 1 by x square dx. Now I guess everyone know how to integrate this. Do you know or not? So if some of you don't know, please, I'm just doing for you, right? So it will be minus this. After this, what will get? See, something like this you will get, right? Something like this you will get. So ultimately what will get, minus q by 4 pi epsilon naught into x to the power minus 1 by minus 1, right? You will get something like this. Now see here, w is equal to, what you will get? So see, this minus will come here, right? So it will be minus minus how much? Plus. So it will be q by 4 pi epsilon naught. Fine, 4 pi epsilon naught you will get as x to the power minus 1. How much you will get? 1 by x, right? Now just put the limit. You get as 1 by r minus 1 by infinity. Now tell me, what is the value of 1 by infinity? What is the value of 1 by infinity? So it will be simple, q by 4 pi epsilon naught 1 by r minus 0. Always remember, 1 by infinity is nothing but 0. So resultant, what will get resultant? Work, right? So you will get something like this. See, w is equal to q by 4 pi epsilon naught into r, right? So this is the total work done from infinity to point P. So as we have discussed, work done is nothing but the electrostatic potential, right? Work done is nothing but the electrostatic potential. So what we will write here? Therefore V is equal to nothing but the potential difference, or potential you can say, right? V is nothing potential. So electrostatic potential V is equal to how much? Q by 4 pi epsilon naught into r. So see, if you remember, this is similar to your electric field. What you have got in electric field? What is the value of electric field? You have got Q by 4 pi epsilon naught into r square. If you remember, in the first chapter we have got this, isn't it? In the first chapter, what you have got? Q by 4 pi epsilon naught. Are getting point or not? So this is the value. See, there is only change, that is it is a square and it is a, sorry, this is a square and this is a single r, right? Is it clear? So just the change in the distance. Fine. So now we are going to see in terms of graph how the graph looks alike, right? We will just see the variation of graph also in electric field as well as the electric potential. So let us plot a graph, like let's say this is a distance, because if I see here, so I can see from this V is directly proportional to 1 by R, isn't it? From this equation I can say V is directly proportional to 1 by R, because this term is nothing but a what? Constant, isn't it? Q by 4 pi epsilon naught is nothing but a what? Constant. So only variable is what? R. So V will be proportional to R, 1 by R, and if I break this, what I'll get? E will be proportional to what? 1 by R square. So R is nothing but a distance, right? So I will just plot in terms of distance and E and V, right? I'll just plot as E versus V, means both I will plot here. Fine, both I will plot here. So if you see, if I just plot the V, that is a potential, electric potential, so you'll get a graph something like this. Fine, you'll get a graph something like this. This is a V. But if I plot a graph of as electric field, so I will get something like this. Fine, so I will get a graph something like this. Fine, so see, at one point they have met here, they have intersected each other. Now the next question will be, now you tell me at what point these two V and E will be equal. At what condition that electric potential and electric field will be equal? Can you tell me? Can anyone can tell me at what point, at what condition this V and E will be both equal? Can you tell me? So answer very simple. See, V and E both depends on R, right? So if you take the value of R as 2, right, so it will become what? How much? 4. They are not equal. But if you take, if R is equal to 1, if I take R equal to 1, so see what will get? What will get? Put it here, you get V is equal to Q by 4 pi epsilon naught into 1, right? And if I put again the value of R in the electric field, what I'll get? Q by 4 pi epsilon naught into 1 square. See, 1 square how much? How much will get? 1 square is nothing but what? 1 only. So Q by 4 pi epsilon naught. And this will also get Q by 4 pi epsilon naught. Means I can say at 1 meter, means this distance must be what? 1 meter, isn't it? This distance must be 1 meter or 1 kilometer, whatever you can take, right? At this point, right, you will get E is equal to V. Is it clear, everyone? What will get? At R is equal to, when R is equal to 1, then what will get? E is equal to V. Is it clear? This is a very important fact that we came to know here, right? So at R equal to 1, what will get? E equal to V. So that's all for your electrostatic potential due to a point charge. Fine. So in our next class, we will discuss about the dipole. Fine. So see you in the next class. If you have any doubt, please feel free to ask. Is it clear?